and welcome to what I can only assume is my last 2x03 2Go3 tutorial video for the semester. Of course, if I get some requests from my few but faithful followers, I will entertain making some more if you're interested. But anyways, this is the solution to Cournot Duopoly. I'm going to show you the slow way first, and then we'll show you a little shortcut you might be able to use on the final. So anyways, a market is served by a monopolist with a total cost of 4y squared minus 10y plus 20. Quantity is 100 minus p. And just as a little aside, if you want to, what are the price and quantity of this monopoly? I'm not going to give you the answer to that, but it's something to do. An entrant with actually, I guess I can give you the answer. That's fine. An entrant with total costs equal to y squared minus y plus 30 is considering entering the market. If the monopolist is expected to behave in a Cournot manner, what are market quantities and price? And now suppose, this is part two, that the entrant has the same total cost equation as the original firm. What are the prices and quantities in that case? So go ahead and pause, take your best shot, and I'll show you how it's done. Okay, so I'm going to probably have to flip back and forth a little bit because I didn't do my little cooking show thing where I've prepared something here. So TC equals 4y squared minus 10y plus 20. TC entrant is y squared minus y plus 30. Q is 100 minus p. And I apologize in advance that these numbers don't work out so well. Honestly, I just couldn't be bothered. It's really tests your knowledge if you get a weird answer and you're confident enough to stand by it. So okay, so it's a lot like solving a monopoly problem. We're gonna make a marginal revenue function, make a marginal cost function, set them equal. Another thing you might have seen is just making a generic profit function and maximizing it over quantity. Either way is fine. I'm going to do the profit function and then show you how it is basically just marginal cost equals marginal revenue. So we'll make a profit function for firm 1. Right, we're going to do the same thing here. Since we're maximizing over Q, it can't be our dependent variable, so this one's really easy to switch around. Look at that. So equals, right, price times quantity, just like we always did, only now we have quantity 1 and quantity 2. And of course this big Q is actually just Q1 and Q2 together, so minus both of them. Okay, so that's our total revenue, and then we'll do less total cost, which is just a straight copy from the question. And I'm going to change my y's to Q1s because that sort of just makes sense. Okay, so, and of course that all goes in brackets every year on the test. People mess that up, but you guys aren't going to be midterm tested on this, so it's probably less of an issue, although you will get the wrong answer if you don't have those brackets. So of course, as with any maximization, we're going to maximize this over Q1. That's a Q down there, don't be confused by my inability to write. Excuse me. Okay, so this is the result of me taking this derivative, and you'll notice that if I split this here and take it to the other side, right, because this is a maximization problem, so this equals 0. Always know why you're setting something equal to 0. But if I take this component to the other side, this is marginal cost, right? And this part over here would then be marginal revenue, right? So this is total revenue. I've taken the differential, so this is marginal revenue, right? And this is total cost, and I've taken the derivative, so it's marginal cost. So if I just split this up and set marginal cost equal to marginal revenue, that's basically what I'm doing anyways. But the nice thing about using a profit function is that right off the bat I can just group terms on this side. So that's what I'm going to do now. So I have 100 here and a 10 here. Okay. And I have a minus 2Q1 and a minus 8Q1 for a grand total of minus minus 10 q1 minus q2. Okay, and from that, since that is equal to 0, I can find that q2 equals 110 minus 10q1. Okay, so now we have two unknowns, one equation. Well, we need another equation. So let's go ahead and do the optimization for the second firm, the entrant, using this cost function. So max pi 2 with respect to q2. And I'll just set up this function exactly like I set up the other one. Okay, so this is our profit function, and I'm just going to come up and start a new line up here and say that d pi 2 dq2 100 minus 2q2 minus q1. Okay, and then minus 2q2. Sorry, this should say q2 down here. Minus 1 equals 0, right? Because it's the maximization. And again here, this part that I'm sort of waving my pointer around right now is marginal cost. And this point over on the left, the first three terms, are marginal revenue. So again, it doesn't matter how you do it, whether you create the profit function or whether you set a marginal cost function equal to a marginal revenue function, you're going to get the same answer because it's exactly the same problem. That's how we get the optimality condition that marginal cost equals marginal revenue in the first place. So I've got some like terms here. Oh, and I did what I shouldn't have done. This should be plus 1. Hopefully some of you were screaming at your monitor in abhorrence of this terrible math. Okay, and that's equal to 0. So again, I want to solve for q2, so I can just set these two things equal to each other. So I'm going to do that. So this is q2 equals 101 divided by 4 minus q1 over 4. Okay. So now, naturally, I have two equations, two unknowns. Let's just come up with a solution here, right? 110 minus 10q1 equals 101 over 4 minus q1 over 4. Okay, so this will be minus 9 and 3 over 4. And this will be, ooh, that's nasty, 339 over 4. Okay. So, yeah, we might as well get rid of the 4's here. So this is actually 4 times 9 is 36, 39. So this is 39. Geez, almost forgot a q1 there. q1 equals 339. Okay, so q1 is looking like it's in the neighborhood of 8 and something. And again, as you might have guessed, I haven't done this ahead of time. But that's okay because I tend to make fewer mistakes that way. So this is 8 point, let's call it 8.69. And with our equation for q2 over here, we can come up with an expression for q2. Okay, so 110 minus sorry, 23.1. That seems better. Okay, so we have an answer for q1 and q2. Now let's find the price because that was asked of us very reasonably. So P equals 100 minus Q. And again, something that I see fairly frequently that just drives me bonkers is that they have a separate P1 from P2. Part of being a Cournot duopoly is that there's no differentiation among the products. So basically, a unit of no one would be willing to pay more for a unit from firm 1 than they would be from firm 2. If they are, you get what's um, it's not a monopoly problem, but it's a different kind of problem. If you have some sort of substitutability, you wind up with two different demand functions. So anyways, it's 100 minus and then Q1 plus Q2, just like we said when we were doing the profit function. And if I do that, I get that the price is 68.21. Okay, so that's all well and good, but it's fairly labor intensive. So I'm going to go ahead and basically redo the whole problem, but show you some sort of neat tricks, or a neat trick, I suppose, that you can use to really cut down the time given certain assumptions. Okay? So I have now that TC 4y squared minus 10y plus 20. Just going to double check and make sure that's right. Yep. And then P is 100 minus Q1 minus Q2. Okay, and now firm 2 has this same total cost function as firm 1. So let's set up a profit function for firm 1, just like we did before. Right, and it's going to be Q1 times this 100 minus Q1 minus Q2. And then we'll subtract from that total cost. And again, I'll put these in terms of Q. Incidentally, it sort of makes sense to really be careful with your subscripts because you have a Q1 and a Q2 and you're going to differentiate across only one of them. So if you're not careful with your subscripts, sometimes you can sort of confuse yourself out of a right answer. So just something to be aware of. And we're going to do our d pi 1 dq1 Okay, so we've got our profit maximizing condition, 110 minus 10 Q1 equals Q2. That may look really familiar because it's the same thing, right? So now here's where our little assumption comes in. We have sort of a symmetry. It's called symmetry in the problem, right? Because the profit function for firm 1 is going to be exactly the same as the profit function for firm 2 because they have the exact same marginal cost or total cost function, and they show up exactly the same way in the demand function. So here we are. By that logic, right, if both firms are doing the same maximization activity, right, they should get the same answer. So from that, I can say by symmetry, Q1 equals Q2. Okay, and now I can just go ahead and set that, make that true, right? So 110 minus 10 Q1 equals, and since Q2 equals Q1, right? This is now my second equation, right? I have two equations, and now I have I had two unknowns, and now I actually have two equations because Q2 equals Q1. So I can just substitute that into my best response function here, and I'll get this response. Okay, so now 110 equals 11 Q1, and Q1 equals 10. Oh, that worked out really nice. Trust me, that's absolutely a coincidence. So since Q1 equals Q2, then Q2 also equals 10. And then our pricing function is P equals 100 minus 10 minus 10. P equals 80. Okay. So the reason this works, right, is because we're taking the same maximization activity by the same firms. What you cannot do, and don't try to do this, I've seen this done before, is set Q1 equal to Q2 before you've taken this derivative. Okay? Um, this derivative is absolutely imperative that Q1 be separate from Q2. And the reason that that's true is because, right, in a Nash equilibrium, you're deciding your best response taking the other player's action as given. Okay? If I, in this framework, set Q2 equal to Q1 over here, right, then I've basically messed everything up because I'm saying that basically firm 1 chooses firm 2's output. Okay, that's not how this works. Firm 1 chooses firm 1's output, taking firm 2's output as given, which is why we treat this Q2 as a constant. Okay, so don't do that. Don't screw that up. If you are confused, don't use the shortcut. If you aren't sure what I mean by this symmetry principle, come to my office and talk to me, or just avoid it altogether, because I assure you, if you set up the profit function for firm 2 and take the derivative with respect to firm 2's quantity and do all the hoops that we did in the first part of this problem, you will get the same answer. But this is just a really nifty shortcut that you can use on the exam. Is just using this as your second equation for your unknowns because they're the same firm undertaking the same maximization problem in the same market. So I hope that you've enjoyed these tutorials. If you're watching them, please, if you comment on the usefulness or something that you'd like to see, and of course if you comment on a video about something that you want to see before the exam, or a problem that you're not sure of, or another example that you want, or just a clarification, I'd be happy to help you. Also, I'm in my office, KTH 706. Anytime you want to drop by. I think I've had one drop in this semester, whereas I'm used to 30 or 40, so it's been kind of quiet. Not that I'm lonely or anything. But anyways, good luck on your final exam if I don't make any more videos or don't see any of you.